Section 5.7 is on solving linear equalities in one variable. So an inequality is a statement that uses one of the inequality symbols, such as less than or equal to, greater than or equal to. When I solve an inequality, I can write the solution with the inequality symbol on a graph or an interval notation. And we're going to be answering our questions in all three of these ways. If I have an expression like x is less than 5, that represents all numbers that are less than 5, or x is less than or equal to 5, all numbers are less than or equal to 5. So to see that difference on the graph, when you have the equal bar, you have a filled in dot at 5, 5 is included. If there is no equal bar, there's an open circle around 5 to say 5 is not included itself, but all numbers strictly less than it are. In an interval, the open dot would be represented by a parenthesis around the 5, and the closed dot, the solid filled in, is represented by a bracket. Sometimes you'll see the parentheses show up on the graph, or the bracket show up on the graph as an alternate graphing notation. The same applies for the greater than inequality. Greater than inequalities are going to head towards the right, numbers greater than 5. If there is no equal bar, you'll either have an open dot or a parenthesis. If it has an equal bar, greater than or equal to, you either have a closed dot or a bracket. In example 1, we want to write the inequality in interval notation and graph the values. Okay. I usually do my graphs first right here, and my graphs just need to have the number that we are looking at x greater than -3, so graph where -3 is. And if it's x's values that are greater than -3, we're going to be heading towards the right, not actually including that value, so have an open circle, and we'll be heading off towards the right. That would be an acceptable graph. Now the interval for this is going to be all values starting at -3 but not actually including it, so parentheses around that -3, up until the highest possible value, which would be represented by infinity. Okay, let's look at the next one. In this one I want x less than or equal to -1. So if I plot -1 on a number line, I know that I have an equal bar in my inequality, so we're going to put a filled in dot there. And we want numbers less than or equal to, so we're going to head off towards the left. Now intervals always come in numeric order, the smallest value, then the largest value. The smallest possible value is represented by -infinity, and the largest possible value, the value you're going to stop at, is -1. We do include -1 by using a square bracket there because there is a bar underneath the inequality symbol. It has an equal bar. Okay, part C and D. Part C, we have 2 is our value we're looking at. These are x values greater than or equal to 2. There is an equal bar, so I get a solid dot. Greater than or equal to heads off towards the right. Notice that when I draw my number line, I can see if I'm going to have positive infinity or negative infinity by whether I draw to the left or to the right. 2 is the smallest value, so I start my interval with 2, bracket around the 2 because of the equal bar, because of the solid dot, and comma infinity representing the largest possible number over there on the right. Last, we have 4. 4 gets an open circle. 4 is not actually included. X is less than 4. Less than 4 values to the left. The smallest possible value, if you were to go all the way down, would be -infinity would represent that. Up until 4, 4 being the largest, but 4 is not actually included, so parenthesis instead of a bracket there. Okay, let's look at the next page. We're going to develop some rules for working with inequalities on this page. Consider the inequality 6 is less than 12. What happens to the inequality sign if you add the same thing to both sides? So, if 6 is less than 12, and you say, for example, add 1 to both sides. 7 is less than 13 is your result, and that's still true, right? So the inequality symbol is going to stay the same. Can you subtract something from both sides? Right, you start with 6 is less than 12. If you subtract something, say 3, from both sides, that would give you 3 is less than 9. 3 is less than 9 is still true, so the inequality symbol stays the same. let's say, so addition and subtraction are completely okay. You can, just like solving an equation, you can solve an inequality by adding or subtracting to both sides. So let's check out what happens with multiplication and division. So 6 is less than 12. Let's say you multiply both sides by 3. 6 times 3 is 18, less than 12 times 3 is 36. That's still true. So if you multiply both sides by a positive number, the inequality symbol stays the same. Let's say you divide both sides by the same thing. Let's divide both sides by 2. So that gives us 3 is less than 6. That's still true. The inequality symbol stays the same. All right, now we're going to get down to multiplying both sides by a negative number. So for example, we'll multiply both sides by negative 1. If you multiply both sides by negative 1, that gives you negative 6 is less than negative 12. This is not true. To make it true, you must change the inequality sign, right? To make it true, you need to switch the inequality symbol to the other inequality symbol. Okay, what about dividing both sides by a negative number? If it was 6 is less than 12, and you divide both sides by negative 2, that gives you negative 3 and negative 6. Negative 3 is greater than negative 6, so once more you have to switch the inequality symbol to make it true. Alright, so that kind of helps us develop this rule. When you're solving an inequality, take the variable by itself. You can add and subtract a number to both sides with no problem. You can multiply both sides by a positive number, no problem. But if you multiply or divide both sides by a negative number, you must reverse the inequality sign. If that number is negative and you're multiplying or dividing, you're going to switch the sign. So let's do some practice problems. Solve the inequality. All right. So I solve it just like an equation, watching carefully if I change the inequality symbol or not. So 3x plus 5, we're going to subtract 5 from both sides. This will give us 3x is greater than or equal to 9. And then divide both sides by 3. I'm dividing by a positive number, so I'm not changing the inequality. I just have x is greater than or equal to 9 divided by 3 is 3. Now when I answer this, I'm going to answer as an inequality, a graph, and an interval. So this is only 1/3 of my answer. I'm also going to graph this, show where 3 is, closed circle because of the equal bar. X values are greater than 3, so I'm heading off towards the right. Again, closed circle or equal bar would start my interval with a bracket around the 3 up into infinity. Infinity always gets a parenthesis, by the way, never a bracket, because it's an idea that you can't actually reach. We're just approaching it. All right, part B. Let's start by subtracting x from both sides. That'll give us negative 9 is less than or equal to 3x. And I'm dividing by the positive number 3, so I'm not going to switch the sign. I'm dividing by a positive number. So negative 3 is less than or equal to x. Now, it's often more convenient to write that with the x on the left rather than on the right. So you write it with the x on the left. The open business is towards the x, so you have to switch the inequality symbols. The open business is still towards the x. So it's the same thing to say negative 3 is less than x or x is greater than negative 3. Okay, so if I graph this, I would have negative 3, I would have closed dot, I would have increasing towards positive infinity, and the interval would be negative 3 comma infinity, again with that square bracket around the negative 3. Check out part C. Part C, we're going to start by subtracting 8. We'll get negative 2 is less than 6 minus 8 is negative 2. We're going to divide both sides by a negative 2. We're dividing by a negative number, so my inequality symbol will switch. The number I divided both sides by is negative. So I'm going to flip the inequality and then do my division. Negative 2 divided by negative 2 is 1. So the correct answer is x is greater than 1. So x greater than 1 would have an open circle at 1 and increasing. Open circle corresponds to parentheses around 1 up to infinity. Right? And part D. We've got to distribute here first, so we'll distribute 4 times 3 is 12x, minus 4 times 5 is 20, greater than 5 times 2 is 10x, minus 5 times 3 is 15. Alright, and we solve, just like I would in an equation, making sure I keep the inequality symbol. So I'm going to subtract 10x from both sides. That'll give us 2x minus 20 is greater than negative 15. Then add 20 to both sides to get your 2x by itself. 2x is greater than 5. And divide both sides by 2 to get the x. We're dividing by a positive number, so the inequality is not flipping. We're just going to have x is greater than 5 halves. All these ones turn out to be greater than. That's interesting. So x is greater than 5 halves, open circle, and my interval is going to have parentheses again, 5 halves, comma, infinity. Parentheses because no equal bar, open circle, parentheses. Let's look at the next page. Alright, we've got another one to solve. We've got some distributes to do here. So my first distribute is going to give me 7x minus 7. Then, next distribute, negative 8x plus 16. Right, multiplying 7 by x and negative 1, multiplying negative 8 by x and negative 2. That's less than or equal to 5. Okay? Combine like terms. Negative 7x minus 8x is negative x. Negative 7 plus 16, positive 9. Less than or equal to 5. Solving for x, we're going to subtract 9 from both sides. So negative x is less than or equal to negative 4. And then we're going to divide both sides by negative 1 to get the x by itself. When I divide by a negative, remember that the inequality symbol is going to change. So now it's going to be x is greater than or equal to 4. So on a graph, this would look like 4, closed circle, greater than or equal to, again, so we're going to the right, bracket around 4, comma, infinity. Part F. We're going to solve this inequality with fractions. We know that if we had an equation I wanted to solve with fractions, I would multiply everything by the common denominator, and we're going to do the exact same thing here. So my common denominator is 8, so we're going to multiply everything by 8. 8 is positive, so that will not change the inequality. So we're going to take 8 times 7/8 minus 8 times 5 halves. That's going to be greater than 8 times negative 3/4 plus 8 times 5 halves. Okay? 8 goes into 8 once. That leaves us with 1 times 7, or 7. 2 goes into 8 4 times. That leaves us with 4 times 5 is 20, so minus 20. I forgot to write my x up there. Let's squeak that x in. Don't want to lose that x. It's greater than 4 goes into 8 twice. 2 times negative 3 is negative 6. I'm forgetting my x's all over the place here. There's an x there as well. And 2 goes into 8 4 times. 4 times 5 is 20. Okay? So we've cleared our fractions, multiplying by a positive 8. And now we're going to solve. So get the x's together first. I'm going to add my 6x over. So I'm going to have 7 minus 13x is greater than 20. And then we'll subtract 7 from both sides. So negative 13x is greater than 13. And we'll divide both sides by negative 13 to get x by itself. We just divided both sides by a negative number, so we're going to switch the inequality symbol. X is less than 13 divided by negative 13 is negative 1. So my answers here, x is less than 1. I also need to graph this. Negative 1 gets an open circle. We're less than this time, so we're heading towards the left. And my interval then is going to be negative infinity, comma, -1 with parentheses because there's no equal bar. Let's go to the next page. Some inequalities are three-part inequalities. Instead of x being larger than a number, it might be in between two numbers. So it's in between two numbers. On the graph, that would show up as being in between two numbers with open circles or closed circles. Or it could be one open and one closed, depending on if I have equal bars on just one side or the other. So the interval notation, anywhere you see an inequality with no equal bar, you get a parenthesis. Anywhere you see an inequality with an equal bar, you get a bracket. So you might have some intervals that have mixed parentheses and brackets depending on if they are the same on both sides of the inequality or not. So let's solve these inequalities. The rule for solving an equation is whatever you do to one side, you do to the other side. These equations have three sides, so whatever you do to one side, you're going to do to all three sides. So start from the center where your variable is, and we're going to solve for x. I'm looking at 3x plus 1 here. I know that I need to subtract 1. This inequality has three sides, so we're going to subtract 1 from all three sides. -5 minus 1 is -6. This is less than or equal to 3x minus 1 subtract off, less than or equal to 12. Okay? Continue solving. We're going to divide everything by 3. Make sure you're dividing everything, all three sides, since this has three different sides, by 3. -6 divided by 3 is -2. I divided by a positive number, not a negative, so I don't switch the sign. And 12 divided by 3 is 4. So that's my answer. Simplified, x is by itself, simplified in inequality form. I want to graph it, and I want to write the interval. When you set this up on a graph, you always have to have the smallest number first. So that's -2 and 4. And -2 gets a closed circle because of the equal bar here. 4 gets a closed circle because of the equal bar there. And we're looking at numbers between them. The interval is going to be the interval from -2 with a bracket because of the equal bar to 4 with a bracket because of that equal bar. Okay. And again, we're listing the answer in all three of these ways. All three parts are part of my answer here. All right, and the last example. We're going to do the same thing. We've got a couple negatives, a couple decimals. So let's solve for our x. Our x is here, so we need to subtract 5.8 from both sides, from all three sides. 7.3 minus 5.8 is 1.5. That's less than -2.4x, and less than or equal to 13.9 minus 5.8 is 8.1. Okay, so we did our subtraction to get the -2.4x by itself. Now we're going to divide all three sides by -2.4. All right. So 1.5 divided by -2.4 gives us -0.625. We divided by a negative number. The number on the bottom is negative number, so the inequality symbol will switch. We divided by a negative number, so the inequality will switch. Both places, the inequality will switch. Make sure you keep the equal bar in the place where it has one, and don't put a new equal bar if there isn't supposed to be one there. All right, and finish your last division. 8.1 divided by -2.4 gives us -3.375. All right. Now, when I write this down, I should be writing the smallest number first. So we're going to switch the order of this expression. -0.6 is larger than -3.3. So I'm going to rewrite this as -3.375. Now, what symbol? The open bit needs to be towards the x, the pointy bit towards the 3.375. Okay, keep going. Before I write the 6, the pointy bit towards the x, the open bit towards the 6, so I'm going to use this inequality, and -0.625. So we just switch the order. When you switch the order of x and the numbers, that will also change the inequality symbols. But I need to have it in the correct order before I can graph and before I can get the interval. The graph and the interval both require that the smallest number is first. So negative 3.375 will appear on the left of negative 0.625. The negative 3.375 will have a closed circle. The negative 0.625 will have an open circle, and our values for x are in between them. The interval is going to have a bracket at negative 3.375, and it's going to have a parenthesis after the negative 0.625. Again, all three parts right here are parts of my answer. I need all three things to have my answer complete. That's the end of the section.